In this video, we're going to introduce a Python feature known as list comprehensions, which are an incredibly expressive and concise way of defining new list objects. Now, up until this point, when we've created lists, we've written expressions like, list1 equals empty square brackets to create a list, or we've predefined the set of values in a list. In this case, we might then go and append items to the list. So for example, here's a little for loop in which we're going to walk through the values from 1 up to but not including 6, again 1 through 5, and one item at a time we're going to add that item to list 1 with the append method, and then of course we can see that list 1 does indeed contain those values. Well, it turns out that list comprehensions are another way of performing the same task, and they can replace most for loops like the one that you see in snippet 2 here. So here is an equivalent list comprehension. A list comprehension looks a little bit like what you do when you create a list in the first place. It's something that's defined inside a set of square brackets, but it consists of an expression, a for keyword. In fact, it looks very much like the first line of a for statement, and basically what we're saying here is for every item in the range 1 up to but not including 6, in this case we would like to take that item and add it to this new list that we're going to create. So if I go ahead and execute that and then evaluate list 2, you can see that we get the exact same result. And notice that we did not have to call the append method in this case. What happened here is the comprehension automatically iterated through the range of elements we specified, and for every item in that range it simply did what we said to do to the left of the for keyword, which is to include that item in the new list that we're creating. Now, list comprehensions are one of Python's functional style programming capabilities. It's kind of a declarative way of saying what you would like, in this case, to place into a list. And another common functional style programming technique is called mapping. And mapping is the case where you take a sequence of values, and for every value in the sequence you apply an operation to it to produce a new value. So if you have 10 items in your sequence, the mapped sequence will also have 10 items. If you have 5 items in your sequence, the mapped sequence would also have 5 items. So let's go ahead and demonstrate another list comprehension here. This time we're going to do a list comprehension in which we have a little bit more complex expression to the left of the for keyword. So let's focus on the for part of this first, and once again you can see for every item in the range 1 up to but not including 6, in the range 1 through 5, we would like to take that item and cube its value. That is, map it to the cube of itself. So let's execute that list comprehension and see what we get for results. And indeed, you can see that the values from 1 through 5 were cubed. So 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, etc., etc. So that's one common style of functional style programming technique, the mapping operation. Another common functional style programming technique is filtering, where you look at each element in a sequence and you include it in the result only if some condition is true. Well, it turns out list comprehensions have a way of doing that also, and here we have another list comprehension. Again, the comprehension is defined inside square brackets, and what we're saying in this case is we would like to include each item for the items in the range 1 up to but not including 11, but we'd only like to include those items if the given item is divisible by 2. So item %2 says give me the remainder after dividing by 2. If that value is equal to 0, it's an even number. If that value is not equal to 0, it's an odd number. So what we're basically saying is in this range of elements, we only want to include the elements in list 4 if they are even numbers. So let's confirm that indeed that is the case. And you can see even though we counted from 1 through 10, only 2, 4, 6, 8, and 10 were included in the final result. Now, so far we've looked only at ranges of values being used in our list comprehensions, but the item to the right of the in keyword, just like in a regular for loop, can be any sequence of elements over which you'd like to iterate to help produce the values that will be included in the list. So let's go ahead and define a list of strings called colors, and you can see here we have all lowercase strings so far. And let's assume that what we'd like to do is to create a separate list, a copy of colors, in which we have the uppercase versions of each of these strings. Well, that's a mapping operation. Every element will be mapped to the uppercase version of that element and placed into a new list that we're creating via a list comprehension. So let me go ahead and paste in a snippet of code that demonstrates that concept. So in this case, for every item in the list called colors, we would like to take that item and invoke its upper method, which is going to give us back the uppercase version of that string, and that new string is what will then get inserted into the list that is being produced by this list comprehension. So at this point we can go and evaluate colors 2, and we can see indeed we have the same number of elements as we had up above. They're all in uppercase letters, and separately, just to confirm, we can go ahead and evaluate colors to ensure that it was not modified by the list comprehension performing the mapping operation. So you can see that indeed it still contains the same values.